Hello class, here we are with day 2 notes for tangent and secant segments. Notice up here at the top of the notes you have some just definitions: secant segment, external secant segment theorem, and secant tangent theorem. Let's make sure that we know what those words mean as we're looking at the definition here. Recall way back in Unit 6, the first lesson, that we talked about what is a secant. And a secant crosses the circle at 2 points. And then what is a tangent? A tangent crosses the circle at 1 point. And we're going to be looking at secant segments. So of course these secant segments are going to be, with an end point and a start point. Taking a look at the definition here for a secant segment: a line segment formed when two secants intersect outside a circle. A secant segment begins at a point at which the two secants intersect and ends at the point in which the secant exits the circle. So making sure that we can identify two secant segments, and hopefully you can say segment EC and segment ED. Okay, so look at that, and hopefully you know where those two segments are on the circle. An external secant segment is a portion of the secant segment that is outside of the circle. So if I look at the picture to identify what two external secant segments we have, we're looking at those little parts of the secant, and those would be segments AE and BE. Now we need to know this information because this is going to be in our theorem. So our first theorem that we have is the secant segment theorem. And I'm going to abbreviate this with out times all. That's going to be a quick reference to that. So here it says, if the two secants intersect, then the product of the lengths, and what this means is the product of each of the two secants is going to be equal to each other. So it's going to be the outside, which is that external part, times all of the segment. So I'm just summarizing that theorem. Read it over, see if it makes sense. So looking at the picture here, the A plus B, that is your all, times B, that is your out. All times out, out times all, it's the same thing, equals the other one. And C plus D, the two parts, that's your all, times the out. So notice that you're going to be using the outside segment twice, for the all part and then obviously for the out part. So let's look at some examples so you know how this theorem works. And again, this is involving two secants. Remember, out times all. So looking at question A, my first secant is TR. My second secant is TS. And remember, out times all equals out times all. For the first one, the top secant, what is my outside part? 16. What is all of it? Well, I have to add 16 plus 26. Now you could tell me there 42, but I just want to make sure that you understand I'm adding the two parts to make it all of the secant. Let's take the bottom secant. What's the outside part? 18. What's all of it? Well, with a variable, you have to say 18 plus x. Okay, make sure you use a plus sign there. Once you have that equation set up, then you just solve your equation. And of course, you can see it's an algebraic equation. So we're going to do some simplifying. This is all product of 672. Distribute the 18, which is 100. My mistake. 324 plus 18x. Subtract 324, divide by 18, and yes, you're going to get a decimal of approximately 19.3. Let's look at one more. If you want to take a look at question B, again, I'm using the formula out times all. And when I'm putting out times all, I'm going to take my first one. Now notice there's tick marks. So if MN equals 8, LM is also equal to 8. So my out is 8, and my all, I'm going to add 8 plus 8. The second secant is 6, is my out. All of it, make sure you add those two parts together. 2x plus 6. Distribute and figure out that, okay, I get 128 over here. Distribute, I get 12x plus 36. Subtract 36, divide by 12, I get approximately 7.7. Okay, so again, look at the answer key for the third example, just so you know that equals 1 if you want to take a look at that one, solving for x. The next theorem involving a secant with a tangent. Now this theorem is very similar to the last one. And again, I'm going to write out times all equals out times all. So this secant involves a theorem, sorry. This theorem involves a secant and a tangent. And it's the same thing. If you take a tangent, the out times all is equal to the secant out times all. So looking at the formula up here, it says c squared. Well, c squared is c times c. The c is the outside part, and the c is all of the tangent. So this is out times all. The e is the out. The a plus e is the all of the secant. So again, this is the tangent, this is the secant of your formula. Okay, so again, let's look at an example and let's see if you understand looking at the secant tangent theorem. So again, I'm going to write down out times all equals out times all. My tangent, my outside of the tangent is 3.3. What's all of the tangent? 3.3. The secant part outside is 2.2. And what's all of it? Make sure you add x plus 2.2. So you're using the formula for two secants, and then you're also using the same formula for a secant with a tangent. So doing the setup, same thing, out times all. I'm going to say that I don't know how many times here. Multiplying, you get 10.8389 equals 2.2x plus 4.84. Subtract 4.84, divide by 2.2. And again, you're getting decimals here, approximately 2.8. All right, let's do one more. And then hopefully you get the idea that, hey, we're going to be using this formula for the homework. Writing out times all. And the tangent outside of my tangent is 13. What's all of the tangent? 13. Looking at the secant, what's outside? 9. And what's all of it? Make sure, again, you add that. And that could be in any order. You can say 9 plus 5x. You can say 5x plus 9. Doing the math, you get 169 equals 81 plus 45x. Subtract 81, divide by 45, and you get pretty close to 2.0 for that one. Okay, so finding what the x value is. The last part of the notes, just a quick, check for understanding. You might see these questions later on, but again, just to emphasize, what do you have here for question 3? You have a tangent secant using out times all. Question 4, you have two secants and the formula out times all. If you have any questions on this lesson, please reach out to me. Send me an email or during my virtual office hours. Take care.